So what we do is we decide if our elements are going to form an ionic compound. Then we write the formula, and then we also write the name. So the first thing that we need to do is look at our periodic table. And for an ionic compound, we must have a metal and a nonmetal. It could be, in this column, could be nonmetal and metal. It doesn't matter. We just need, somewhere in our grouping, we need a metal and a nonmetal. So that's our first thing, and then we'll look at the formula in a minute. Okay, so the first one, we have lithium. Lithium is here. If you need to figure out the symbol and the name, you can click on the element. So Li is lithium, and magnesium is right next to sodium down here. Magnesium and this Alex periodic table helps me know that these are both metals. Okay, so both metals are not going to form an ionic compound. So then we're done with that row. Okay, the next one is calcium and sulfur. So we go over here, calcium is a metal, and then sulfur over here is a nonmetal. So this will form an ionic compound. We have a metal and a nonmetal. So yes. So the next thing that we need to do here is we need to write the empirical formula. So I'm going to pull up my whiteboard. So we need the compound, we need for calcium and sulfur. So the empirical formula, the first thing that we need to look at is our periodic table. We need to look at the charge that's formed. So when we are looking at our periodic table, we can use the second row, these numbers, and that tells us the charge that's formed. So this that tells you the valence electrons. So this has one valence electron. Sodium is going to give away one valence electron to be +1. So this is +1, +2. This column is +2. And then going away from the noble gases, we have -1 column, -2 column, -3 column. And then carbon usually doesn't form a charge. But nonmetals, -1, -2, -3. So that's something that would be helpful to have on your note card to remember that for ions. Okay, so calcium was in this column. Calcium, everything in this column forms a 2+ charge. So I'm going to write that down really quick so that I remember that. And then everything over here in this column forms a -2. So sulfur is in the -2 column. Okay, so then what we're going to do for the empirical formula is we can crisscross the charges. So if we have a 2+ charge, we can bring that down. And the 2- charge, we can bring that down on the calcium. So this is telling us for every 2 calciums, we need 2 sulfurs. The other way we can look at this is we have a 2+ from the calcium, and we have a 2- from the sulfur. This is telling us if we have a 2+ and a 2-, we just need one of each. So there's 2 different ways we can look at this. We can say, oh, this looks like calcium to sulfur 2, but we need to simplify this. Ionic compounds we simplify. So we can divide a 2 out of both of those and we get calcium sulfur. We don't need to put the number if it's a 1. We don't put the 1 subscript. The other thing that we don't do in the formula is we don't write the charges. The charges are just there like showing our work. We're trying to puzzle out what the formula should be. We don't write the charges in the formula. The other thing is we have to simplify ionic compounds, and the cation always goes first in the formula. So calcium forms a 2+ charge. So usually that's the metal. So usually that's the metal atom that goes first. Some of our ions are cations, and those would go first in an ionic compound. But generally that's the metal. So metal goes first. Don't write charges. Don't write 1 subscripts. Okay, so that's our empirical formula. And then the other thing we have to do here is we have to write the name. So we always just write the name of the metal. And then we change the end of the nonmetal to "ide." So this would be sulfide. And that's it. All right, the next one, we have lithium and fluorine. So lithium is here. Lithium is a metal. Fluorine is a nonmetal. So we have a metal and a nonmetal. Yes, those will form an ionic compound. So what we're going to do is, let's write down lithium, and fluorine, we need to figure out the charges. So lithium is here. All the metals here form a +1 charge, so lithium is +1. And fluorine is over here. It's right next to the noble gases. It forms a -1 charge. So we don't have to write the 1 here either. So we can just put lithium plus, fluorine minus. And then to show our work, we're going to show like we just need 1 fluorine for 1 lithium. So we're just crossing the charges down. Okay, so this tells me my formula will be lithium fluoride. And that makes sense. If this is a plus charge and this is a minus charge, we just need one of each of those to balance out to be a 0 charge. That's what we're trying to do, get a 0 charge. Okay, so this is our empirical formula. So let's go back and type that into Alex. So remember, metal goes first always for cation. Oops, or I have to push yes first. So yes, lithium fluoride. And then we write the name of the metal, lithium, and it does matter spelling, so you can look here and make sure you're spelling it right, lithium, and then space. This is fluorine, but we just changed the end to ide, lithium fluoride. Let's make sure we spell that right. I think it has an O, fluoride. Okay, last one is cesium and iodine. So cesium is here, that's a metal. Iodine is here, that's a nonmetal. Everything in this first column forms a +1 charge. So cesium is a +1 charge. Iodine is over here. It is in the -1 column, so it's going to form a -1 charge. So we have cesium, and we have to get the correct symbol too, so make sure you do that. Cesium is -1, or excuse me, +1. Iodine is -1. So we just crisscross our charges. They're both 1 and 1, so we just need one of each to have the balanced ionic compound formula, the empirical formula. Just 1 cesium for 1 iodine. The metal goes first, or the cation goes first. And then our our name is cesium. That's the metal name. Oh, so yes, that will, because we have a metal and a non-metal. This is cesium iodide. So cesium. Make sure you spell it right. Space iodine. Instead of IO, this is iodine. We're going to change it to iodide. Okay. Check. Let's do another one. So let's see. The first thing that we're looking for is, do we have a metal and a non-metal? So sulfur and barium. So go to your periodic table in Alex. You will get that on the test. You have sulfur is here. So that's a non-metal. And then barium is over here. So even though the non-metal is first, that's okay. We have a metal and a non-metal. So yes, a metal and a non-metal will form an ionic compound. And then our empirical formula, we have to put the metal first. So first, let's go. So barium is here, Ba. So put the metal first, the cation first. It's in the 2+ column. Barium's in the 2+ column. So everything in this second column forms a +2 charge. I'm going to write that down. 2+. And then sulfur is over here. It's 1, 2 away from the noble gases. So sulfur forms a -2 charge. So we write that 2 minus. And then this is like, we can think about this one 2 ways. We can say, oh, I have a 2+ and a 2 minus. So I just need one of each to charge balance. I need 1 2+ for 1 2 minus. That will balance. Or we can do the crisscross method. And we can say we need 2 sulfurs for 2 bariums, and then simplify. We have to divide both by 2 to simplify that. So then we have barium 1, sulfur 1, but we don't write the 1s, so we have barium sulfide, BAS. We always have to put the metal first. The non-metal comes second. And the metal, yep, okay. Okay, and then we simplified. Okay, so that's our empirical formula. So BAS, barium, and then we put the metal first, name of ionic compound. Metal first, barium, and then we're going to change sulfur to sulfide. Okay. Okay, next one, we have calcium and sodium. So we're looking for, do we have a metal and a non-metal? So calcium is here, that's a metal. Sodium is here, that's a metal. So both of these are metals, so that will not form an ionic compound, and that's all we have to do. Okay, next one, we have chlorine, which is over here, that's a non-metal. And we have lithium, which is over here, which is a metal. So metal and non-metal, yes. Chlorine and lithium will form an ionic compound. I'm going to write lithium first because it's the metal, and lithium's in this column here. So this column, everything forms a +1 charge. I'm going to write that down, plus. And then chlorine is over here. Everything in this column forms a minus charge. So I'm going to write that down also. And again, the metal goes first. That's just notation. So metal goes first, then non-metal. And we have 1 plus and 1 minus. So we can think, oh, we just need one of each to have a balanced empirical formula. Or we can do this crisscross. So we need 1 chlorine for 1 lithium. So this will be LiCl. We don't write the ones in the formula. We don't write the charges in the formula. Metal comes first. So that's our empirical formula, lithium chloride. So yes, Cl. Okay, make sure you spell that correctly. This is an L. Sometimes people get that confused. LiCl. And then we put the metal name first, lithium, and then we change the non-metal name to chloride. Okay. Then this one, we have sulfur and bromine. So let's see, sulfur is here. That's a nonmetal. Bromine is also a nonmetal, so this is no, they won't form an ionic compound.